Hello and welcome. So we're going to graph some transformations today. Let's get started. First thing you need to figure out is what are you looking at? Anything that's going to have a parabolic shape, that's going to be an x squared. Okay? Anything that's going to be, I call it a half seagull, is going to be a square root. Anything that's going to be a v shape is your absolute values. Okay? Now keep in mind that for all three of these graphs, in order to graph it correctly, your turning point, your vertex, must be the first point that you plot. Otherwise, it won't plot it correctly, so keep that in mind. Alrighty, so here we have a square root, right? We see that radical symbol, which means you're going to have that half seagull. Now, for those half seagulls, I'd say, okay, the normal points that we plot for these ones, it always starts at 0, 0. So if you plug in 0, square root of 0 is 0, right? Your next point is over 1 up 1, because if you plug in 1, square root of 1 is 1. Your next nice point is going to be at 4, 2. We'll call it a nice point because it's a perfect square. What's the square root of 4? 2, and that's where that point came from. Okay, so your pattern is 0, 0, over 1 up 1, over 4 up 2, and then it'll keep going from there. Okay, so now let's figure out what our transformation is. And I'd say, okay, for our transformation, we see that you have a negative 1/5 being multiplied to x. Now, multiplication implies that you have some kind of dilation going on. Alright? Now, whether that's horizontal or vertical, you have to look at where the number is. Because the negative 1/5 is inside of the radical symbol, inside of your operation, that means that you are looking at a horizontal dilation specifically. Okay? Now, this negative out front implies a reflection. So we have technically two different transformations happening here. We have a reflection as well as a horizontal dilation. Now that dilation can mean either stretch or compression, or shrink, if you want to call it shrink instead of compression. Okay, either or. You say, alright, well, now let's figure that out. Stretching or shrinking. Now, keep in mind that you always do the reciprocal of what is inside with x, with your dilations. So if it's negative 1/5, the reciprocal of that would be negative 5. Because that's technically negative 5 over 1. You just flip the fraction. Reciprocals don't change signs. So if it's negative before, negative after. Now the reason why we use the reciprocal, think about it this way. If you have some absolute value of x equals 10, that means that you would just plug in 10. Absolute value of 10 is 10. So next, you'd say, okay, what if it's 1/2 x? Horizontal dilation. What would that mean for x specifically? Well, that means you'd have to plug in 20 for x. X would have to be twice as much as it was before in order to get 10 back, because half of 20 is 10. It's the only way to get back to 10. And the next one, what if it was 2x? Well, in order to get to 10, you don't need as much. You only need, specifically, you only need half as much. Okay, because 2 times 5 is 10. That's how you get back to 10 on that one. So you started with 10, right? In order to get back to 10, you only need half as much when there's a 2 in front. So in other words, reciprocal, because the reciprocal of 1/2 is 2. Reciprocal of 2, 1/2. Alrighty. So to graph this, once we know our pattern that it starts at 0, 0, you can't change or multiply 0, 0 and have it change places. It's still at 0, 0. Okay? And now your next point is over 1 up 1, but we know we're not going over 1, we know we're going over 5. Now, what direction we talk about when we're talking about over is dependent on that reflection. Left is the negative. So it's going to be not left, not right 1 up 1. It's going to be left 5 up 1. And the reason why the y value hasn't changed, why all three of these will remain the same, is because this dilation was only on the inside. It only affected the x's. Okay? Which means that our next one is supposed to be over 4, right 4, but it's not going to the right. The negative says we're going to the left, and then 4 times 5 That's a negative 20. That's way beyond our graph. We can't even put that second point on there. Okay. Oh, that was like a wonk shape. Not the best, but it'll do. Okay. Assume that these lines are going where I want them to go. But when it comes to these, that would be it. That would be your graph. You plot this point first, then this one, and you would be done. Okay, so do keep in mind that when you have horizontal, it's going to do the reciprocal with stretches and shrinks. Alright, thanks for watching.